I'm going to talk through some of the answers to this as long as I'm making up an answer key. We're looking for the instantaneous velocity, so the instantaneous rate of change. And we know that the instantaneous rate of change is the limit as delta x approaches 0 of the change in y over the change in x. And we'll admit that we as humans right now can only find the instantaneous rate of change by sort of estimating it. What we're really doing is finding the change in y over change in x over some interval, no matter how small. So for A, if I'm looking for the instantaneous rate of change at 2, well, I might take my interval to be, I don't know, on either side of that. And I don't really have to worry because this is a line, so it has constant slope. The slope of the line is 8 minus 5 is 3, over 3 minus 0 is 3. So the slope of the line at any point is 1. So I could say the instantaneous rate of change, the instantaneous velocity here, is just going to be 1. For B, we are not so lucky. So we're looking for the instantaneous rate of change at 2. And I'm going to pick, in fact, I'll just demonstrate. I'm going to pick one interval, 2 to 2.001. 2 to 2.001. So what I'm going to do is put my calculator back in function mode, and I'm going to plug this in. So I have 2 to the x, and what I want to do is second quit. I want to do vars, y vars function, y sub 1, which brings that y sub 1 up onto the screen. I'm plugging in 2.001 minus vars, y sub vars function, y sub 1 at 2. So there's my change in y. I'm going to divide that by my change in x. And I get, as an instantaneous rate of change, I'm going to say it's 2.774. Now, I'm going to see if that's correct by taking another smaller interval. So I'm going to try going between 2.2 and 2.00, let's say 0.1, and see if it makes some difference. So I'm going to take that. I want to insert a 0 in here, so I'm going to insert a 0. And then I'm going to divide by the difference in the x values, 0.0001. And in fact, that's going to give me 2.773. Well, that made a little bit of a change. I'm looking for this to be correct at 3 decimal points. Let me see if it changes if I get a little bit closer. So I'm going to add yet another 0. Divide by 0.00001. And that, again, gives me 2.773. So I'm going to assume that the slope of anything coming in from this direction is 2.773. I'm just going to also show you that if I looked at this from the other direction, maybe 1.999 to 2, so coming in from this side, so I'll have vars, y vars function, y sub 1 at 2 minus vars, y vars function, y sub 1 at 1.9999. And then I'm going to divide that by my change in x. So 2 minus 1.9999 gives me 2.772. Oh, goodness, 2.772. All right, I'm going to try to sort of take an interval on either side of this. So I'm going to do vars, y vars function, y sub 1, 2.00001. minus vars, y vars function, y sub 1, 1.99999, divided by 2.00001 minus 1.9999. I think that's what I did. Yep. Okay. Try again. Anyway, we need to play around with this, but our slope should be 2.773. And we'll have to get a little bit closer to see if this is accurate.